If somebody gives you these numbers are given to you, and you have to find from these numbers statistically extreme points, also known as outliers. Can you do that? Well, that's going to be a difficult task for you just by looking at the numbers. How about this right here? If somebody gives you that these represents heights of people, can you find an outlier over here? Answer is yes, you can, right there. You can see that this guy is the tallest guy, and you can find outlier over here. In this session, I'm going to show you how you can find outlier of data that are numeric in nature, like this one. So let's try to understand the problems with outliers. Okay, let's say you have a mean. Okay, let's say you have these numbers right here, 3, 3, 4, 5, 5, 7. You calculate the mean of these numbers. Basically, you add all the numbers together, divide by the count, and your answer comes out to be 4.5. All of a sudden, this number I changed to 70. Okay, and then you can tell just by looking at this number that this number is your outlier. Okay, it does not belong here. Now, because of the presence of this number, your mean value, you can see that it just changed to 15. So because of the presence of extreme value, okay, and an outlier value, your mean value went from 4.5 to 15. So the presence of the outliers, it changed the mean drastically. Let's look at the median now. Same data set, okay, exactly same data set. And now I'm finding the median of that. Median is average of the middle number. In this case, this is my middle number, and just find the average of that. And the answer comes out to be 4.5. Well, I'm taking the same data set. Now I'm just changing it. Okay, I'm just introducing an outlier value. This is a very big value, and you can see it's an outlier value. So median in this case would be same, right? You take the middle value and you find the average, and the answer is still 4.5. So your median has not changed because of the presence of your outliers. Now let's try to identify outliers. Let's try to see a method that you can use to identify outliers. This is called interquartile range method. The first thing you want to do is order your data set. So this is my data set right here. This is my actual data set, and I order it. And after you order the data set, this is how it's going to look like: 28, 31, 34, 40, 41, and so on and so forth, all the way up to 75. Step 2, then you find your Q1, Q3, and IQR. Now, to find Q1 and Q2, Q3, you have to find your Q2. Q2 is the value which represents the median of your entire data set. So this is my entire data set right here. Find the median of this entire data set, and the answer is 48. Okay, this is my Q2. Okay, then you divide your data set into upper half and lower half. So this right here is my lower half, and this right here is my upper half right here. So first, find your median of your lower half. So the median of your lower half, which is this data right here, the median of this lower half is going to be my Q1, which is this right here. So this is my Q1, which is the median of my lower half. Another name for that is 25th percentile. Okay, you're going to hear the word 25th percentile in literature. All right, 25th percentile. Likewise, this thing is called 50th percentile. All right, 50th percentile. And likewise, now you can also find Q3, which is the median of your upper half. So this is my upper half right here, and the median for my upper half is this number right here. It is going to be Q3, and this is called 75th percentile. Okay, another name for that is 75th percentile. So I know my Q1, I know my Q3. Now you can find your IQR. The formula for IQR is Q3 minus Q1. Substitute your values, the answer comes out to be 8. So I know my Q1, I know my Q3, and I know my IQR. IQR is 8. This is my 44, right? And this value right here is 52. Okay, now we identify lower and upper bounds. Okay, that's what we're going to try to do. We're going to try to find this and this right here, and any values that are out of this, they will be your outliers. So your lower bound formula is Q1 minus 1.5 times IQR. Substitute your value of Q1, substitute your value of IQR. The value of Q1 is right here. Okay, this is my Q1, and I know my Q3 too, and I know my IQR. Substitute these values, and my lower bound comes out to be 32. Likewise, upper bound. Your upper bound is equal to Q3 plus 1.5 times IQR. Substitute your values, and the answer comes out to be 64. So the points that are outside the lower and upper bounds, they are your outliers. So points that are outside 32 and 64, these are my outliers. So this is my 32 right here. This is my lower bound, and my upper bound is 64 right here. Okay, this is my 64. So any point that lies in this area, in this range, okay, these are my outliers. Well, now if you go back and if you look over here, you can see that this point, these 2 points right here, these two and these two, they are outside the range of 32 and 64. So these are my outliers. So 28 and 31, 68, 74, 75. These values represent my statistically extreme points in my data set. So these are my outliers. Final result, this is my actual data set, right? And I ordered it, by the way, over here. You plot this on a number line. If you plot this on a number line, this is how your data set will look like. Now you can tell just by looking at this that these values, okay, these values, they kind of like seem like extreme values, right? You can actually find that now. And by looking at this, you can also tell that these are my outliers. Okay, so these are my outlier values over here. So I'm able to identify my outlier this way. This one right here is my minimum, which is 32, right? This is my lower bound, and this is my upper bound right here. This is my 64. So any values that are outside the range in this area and in this area, they are my outliers. Now I'm going to show you how you can identify outliers using Z-score method. It's a two-step process. In step one, you convert your data. The data that's given to you, convert into Z-score. You use this formula right here. This is the formula you use to convert your data into Z-score. The Z-score measures how many standard deviation your data is from its mean value. In essence, it measures how far, okay, how far you are away from your mean value. So this is my mean value and how far you are. The greater your Z value is, the further away you're going to be from your mean value. Step two, you set up your threshold. For the most part, generally they use number 3 as your threshold, but you can use 2.5, 2.3, depending on your need. Okay, you can set up your own threshold. So if your data falls outside the threshold, then it will be considered as an outlier. So let's say you pick up a 3 as your threshold. This is your threshold right here. Okay, 3. So if your data falls in this region, or if it falls in this region, okay, then it will be considered as an outlier. So this is what's happening in your step 2. So let's try to understand this through an example. Let's say you have to find outlier in this data right here. This is the data that's given to you. You have to find outlier. Step 1, well, calculate your z-score. Now to find your z-score, you need to know your mean value. You need to know your sigma. So I calculate my mean value. I basically take all these numbers. Okay, I took all these numbers right here. Okay, add them all together, divide by the total count. Okay, my answer came out to be 48.28. Then find your standard deviation. I'm assuming you know how to calculate standard deviation now. So once you know your mean value, once you know your standard deviation, now you can find your z-score using this one. So let's calculate this one, 28. Well, convert your 28, okay, into z-score, and the way you do this thing is 28, right? 28. I'm actually using this formula right here. Okay, 28 minus your mean value, which is 48.28, and then you divide by your standard deviation. The answer is 8.53, and the answer is right here, minus 2.38. Okay, then you can do the same thing with the next one, 31. So I did 28. Now you're going to do the z-score for 31. Calculate the z-score for 31. It will be 31 minus 48.28, same formula. All right, and you divide it by standard deviation. Okay, and your answer would be right here, minus 2.03. And likewise, you can calculate the standard the z-score for the next value, which is 34 right here. Okay, 34, and your answer would be minus 1.67. Okay, so assuming that you know now how to calculate z-score, now so now you have this data right here. Okay, this is your original data, and now you have calculated all my z-score. This is all your z-score right here. So for this one, my z-score is minus 2.38. For 31, my z-score is minus 2.03, and for 34, my z-score is minus 1.67, and so on and so forth. So these are my data right here. Okay, and these are my z-score for each one of these points. Now let's define our threshold. So in this case, I'm defining my threshold as 2.3. Okay, I'm just picking a number. I could have picked up like 3, some other number, doesn't matter, but you just define your threshold. So I'm defining my threshold as 2.3. 2.3 would be somewhere, let's see, 2.3 would be somewhere over here, right? So it's going to be somewhere over here. All right. So any data, okay, so this is my threshold right here. So any data, okay, any z value that is in this range, okay, that would be my outlier. Any data that falls in this area, that's my outlier. Well, you can see just by looking at this, you can tell this one is falling out of that range. Okay, you see that this is minus 2.38 would be in this area, Minus 2.38 will be over here. This threshold, okay, I'm assuming that this is minus 2.3, okay, and because I'm taking it minus 2.3, and this threshold is going to be plus 2.3. 2.3. So any value, and as you can see, minus 2.38, it falls in this side. Okay. Then let's look at another one right here. Look at this one, 2.31, 3.01, 3.13. These ones, they fall in this side of your threshold. And because they fall on the other side of your threshold, they are your outliers. So 28, 28, 68, 74, 75. Okay, for this value, the corresponding value is right here, 28. And for these three values, the corresponding values are this right here. So my 28, 68, 74, 75, these are my outliers. So which method should you choose to determine your outlier points? Should you use IQR method or should you use Z-score method? Well, these are just guidelines. Okay, so these are just guidelines to follow when you actually want to, when you have to decide which method to use. These are not rules. They are just like a little helpful tips. So if your data is non-normal, in other words, if it's skewed or if it's a small data set, let's say numbers like this, if it's a small data set, then use your IQR method. If your data, you do not know your distribution of your data, okay, if you do not know the distribution of your data, use your IQR method. If your data is ordinal or if it's not strictly continuous, for example, look at this 3, 2, 4, 1, 3, 4, 9, 93. These are like all integer numbers. Okay. If your data is like this and it's small data set, use your IQR. On the other hand, use Z score. When you know your data is normally distributed, right? It's a bell shaped curve, and you know it's a large data set. Okay? It's a big data set and it's a continuous value. So in that case, it's a good idea to use your Z score. So now let's focus on how to remove your outliers. Well, there are a few basic techniques we can use. The first one is trimming. So let's say this is your data set, right? This is your data, and you can see this one right here is your outlier value. You see all my values are 1, 1, 2, 2, 2, 2, 2, 3, 4, 4, 5, and then all of a sudden you have these big values on either side of my data set. So on this case, what I can do, I can just remove minus 40 and I can remove 56, 89 completely, and then I'm left with this data set right here. Okay, so this is one solution. Now, in this solution, basically your size of your data set goes down by somewhat. Okay. Now, this is a good solution if you know that your errors, that your outliers basically were from data entry errors or there were some measurement mistakes. So if you know that's the reason, it's a good solution. Basically, you can remove them. Another one is your capping or vinsorizing them. So basically what you do, you start with the same. This is my data set right here. Okay, and these are my outlier values. So let's say you have identified your outliers. Okay, these are your outliers. And what you do, you define a threshold. And in this case, let's say I define my threshold as 1. This is my threshold. Okay, and I'm saying that all my values, okay, that is on this side, I'm going to replace them with 1. And that's what you do. You just replace that with 1 right there. Same thing on this side. You replace all value with the threshold. In this case, my threshold is 5. So any value that is on this side, replace them with 5. And I replace my value 56 and 89 by 5. One of the advantage of this is that your data set size is preserved. So if this one has, let's say, n number of elements, this will also have n number of elements. They would not change. So this is a good when you want to avoid bias. So this is a good solution if you want to avoid your bias. Another solution would be replacing with mean or a median. Okay, another name for that would be mean imputation or median imputation. So same data, right? And let's say you identify your outliers. These are my outliers right here. This one and these two. So what you do, you replace them with the mean value. Let's say my mean value is m. Okay, so you just replace that with m, and same thing with these ones. Okay, just replace them with m and m. M could be mean, m could be medium. So basically, you're replacing with the more typical ones. Okay, and this is a good solution when you know that your data set is small and every record matters.